Hello everyone, last time I've uploaded a project called Speech Emotion Recognition, and unfortunately I couldn't show you the end result at that time, so I've already run the code from last time, and if you have also run a code, then it should give you the result like this, and it has the number of epochs, and I've set the number of epochs to 500, and it has loss, and loss is the value uh, denoting how close the predicted answer is to the true answer, and the accuracy is the number of examples that the model has predicted correctly, and the accuracy is evaluated on the trained data, and the validation loss is the loss evaluated on the validation data, and the validation accuracy is the accuracy that is evaluated on the validation data. And to measure the performance of your model, then you should use validation accuracy, because the what we are um, interested in is how well the model is gonna do on the examples that the model has not seen. So when it comes to train accuracy, then the model is gonna reach 100% after having infinite number of times of epochs of training, because the model keep seeing the examples, then the model is gonna be 100% accurate on the examples the that the model has seen, because the model has been trained with the examples, with the same examples. So if you go down, keep going down the seeing the result, then you can see the train accuracy keeps increasing down to the when it reaches more than 70 epochs, then the model can predict all the trained examples correctly. However, when it comes to validation accuracy, then it has decreased. So we call this as overfitting. So overfitting means that the model can do well on the trained data, but if it is evaluated on the test data, then the model performs poor. So the model performs well on the trained data, but the test data. So we call this phenomenon as overfitting. So to avoid overfitting, we can set up patience, and it usually we can set up patience as number 6. So let's go how we can do early stopping with patience. So I've um I have written down all these validation accuracies to my Excel file, and the initial value of patience you can set it to 6, and as the number of epochs keep going up, then we check the best accuracy, and if the validation accuracy is less than the best accuracy that has been found so far, and we decrease the patience by 1, and if the validation accuracy is found which is higher than the current best accuracy so far, then we set the patience to the initial value of patience, so which is 6. So let's go. So best the accuracy currently 0.1833 and 0.155 at epoch 2 is less than the best accuracy. So what we do is 0.1833 and the patients decreases by 1, and again decreases by 1, and best accuracy it's still 0.1833. And this time, if it is greater than or equal to the best accuracy, we set the patients to the initial value, which is 6. So best accuracy 0.1833 still, and 0.1500 it is less than the best accuracy, so it decreases, patients decreases. So best accuracy is 0.1833, and this time this validation accuracy is greater than the best accuracy. So we set the patients to the initial value of patients 6, and the best accuracy is updated to 0.2333, and 0.200 is less than the best accuracy, so decreases by 1, and 0.2333, and at epoch 8, it is less, the validation accuracy is less than the best accuracy, so it's gonna decrease by 1, and still best accuracy is 0.233, and less, so it is less than the best accuracy, decreases by 1 to 3, and still to 3, and this time 0.22 should be 2, and 1, and this time it is 0.333 is greater than the best accuracy found so far, so the patience is set to 6, and the best accuracy is updated to 0.3333, and this time 0.3167 is less than the best accuracy, so patience decreases by 1, and this time we found best validation accuracy greater than the best accuracy, so the best accuracy is updated to 0.350, and now the patience is set to the initial value of patience, and this time because 0.1833 is less than the best accuracy, so patience decreases by 1, and now it is validation accuracy 0.3667 is greater than the 35%, so patience is reset to 6, and best accuracy is 0.3667, and now it is going to decrease 5 and 4. Now it's 4 because 30% is less than 36%, and 3, again 2, and 1, and this time you see 0.3833, which is greater than the best accuracy found so far, so patience is set to 6, and the validation best accuracy is updated to 0.3833, and now again it decreases, and you see 41% classification accuracy, so it is set to 6, so 0.54167, this is the new best accuracy, and 0.300 less than the best accuracy, so the patience decreases again to 4, and 4.0 is less than 41% to 3, the patience decrease, and to 1, and to 1 and 2 0, and you see here 0.4167. However, because the accuracy, the patience has decreased to 0, so we are going to stop here. So the evaluation accuracy that we can suggest, that we can show you for the performance of this model is 41.67%, which means that the model can predict the emotion of the person speaking and 41% correctly. So in Keras, if you want to do early stopping, you can use callbacks from Keras. And if you go to early stopping to Keras official site, then you can you should first import callbacks. Then I'll show you how we can do. So let's go here and let's code another block and callback import callbacks from Keras.callbacks. So we should import it from Keras.callbacks, import early stopping, early stopping, and let's um, let's do early stopping. So let's copy this code block, and we are going to modify to our example. So callback because we have imported early stopping, we can remove this part early stopping, and we are going to use accuracy for our model, and let's set the patient to 6, and we have already declared our model, so we are going to remove this part and compile. We have already compiled our model, so remove this. And if you see, actually we don't need this length part as well. So callbacks, you need to pass the declare the callback to callbacks parameter. So callbacks to callback, copy this, and you can maybe put it here, paste it here. So let's remove this part and run again, and let's see here's all on metric accuracy, which loss accuracy validation. So I've passed wrong arguments, so it should be not validate, and it should be validation accuracy. So let's go up and let's change it from accuracy to validation accuracy, and run again. So even though the number of epochs is 500, and because we have set early stopping to validation accuracy, so the model stops at epoch 11, and which um, which has applied early stopping. So if we see here, because the patience is set to 6 and 6 to 6, 5, 4, and to 6, 0.36 new best accuracy, and to 5 and to 5, 4, 3, 2, 1, and 0. So now it stops. And actually, my example, I have shown that I have included the validation accuracy, which also I also set the patients to the initial patients for the same validation accuracy, but actually there are some different ways of implementing early stopping, and and as you can see for this Keras API, it does not treat the validation accuracy that is that is same to the best accuracy. So in this case, maybe you can increase the number of patients that if you assume that we can find a better accuracy, better validation accuracy after more number of epochs. And here you may wonder that if we set the patients and if the accuracy, higher accuracy can be found after more number of epochs, and we could not get the higher accuracy because of the patients. And actually, the patients depends on your experience. And if you set patients to too small number, too low number, then the model is not going to um, converge well. And if you set it to too higher number, then the Apple is gonna run forever. However, um, usually patients to for multimedia data to 8 is a good choice. And because even if you find the validation accuracy, test accuracy that is higher than the found best accuracy so far, after 100 epochs of decreasing, validation accuracy decreasing, and the validation accuracy goes up after 100 epochs of going decreasing, then we cannot trust the model because it is the chance of getting the validation accuracy should be consistent, but as it is not constant, so we should always um, measure the performance with specific patients. So let's say um, we get the best validation accuracy at like 50, 56, 87%, and at Apple maybe 67. Then from Apple 68 to 60, Apple maybe 268, we get validation accuracy of 47%. And if we get at Apple 269, then the validation accuracy we get validation accuracy maybe 96%. Even though this validation accuracy is higher than the best accuracy found at Epoch 67, and if the patient is set to set, then the model is not it's gonna stop after 76, epoch 76, and we cannot give this result for the performance of our model because suppose that if you get the validation accuracy just after like this 200 epochs of going decreasing, then what is important when you um, create a model, then in the statistics point the result should be reproducible. The result should be reproducible, and if the validation accuracy is found and which is not consistent, which means that it has not been found after the validation accuracy constantly having going up through the epoch so far, then we can not trust that the result can be reproducible. So due to this reason, you should set the patience and you can set it with Keras with a list hopping, and it's gonna also save the um, number of times of training. And up to here, I've explained about list hopping and patience and how you can do it with Keras with callbacks library. So I'm going to finish off here. Thanks for listening. Goodbye.